Hey, this is Jim from DTRSec. This is the 19th video in the Reversing in REnigma series. In this video, we are going to demonstrate how to connect the Ghidra Debugger to REnigma. Let's do a quick overview of connecting Ghidra to REnigma. First, we will give a quick overview of the REnigma console feature. Second, we will launch a replay and load a specific execution point to examine. Third, we will launch a REnigma GDB remote debugging server on that paused replay in the REnigma console. Fourth, we will create an SSH tunnel to allow Ghidra to communicate with the debugging server. Fifth, we will demonstrate connecting the Ghidra debugger to that local SSH tunnel port. And finally, we will use Ghidra to view CPU registers, memory, and examine code. Before demonstrating Ghidra connected to REnigma, let's first do a quick overview of the REnigma console. The console is a virtual machine pre-configured with access to the REnigma API. It allows you to run REnigma tools that use the REnigma API, or write your own custom tools. In the REnigma console, you can make API calls via Python, and some high-level operations are available via REST. The console has long been a part of the REnigma GUI as a tab, but now it is also available via SSH. Let's SSH into the REnigma.io server with SSH demo at console.renigma.io-p2000. And then we can run the lsrex tool to demonstrate usage of the REnigma API. Next, let's launch a replay in paused mode, and then restore an rsnap to pause the VM at the desired execution point. This is the execution point of a TCP connect operation to a .ru domain. Now, back in the console, let's set up the REnigma GDB remote debugging server. The tool to do this is called regdb. To connect to the running replay, you can run regdb-connect with the replay ID from the replay URL. Now you can see the local port number is 2500. Next, on your local machine, you need to set up an SSH tunnel to the GDB server. In this case, we are using the REnigma console SSH server on port 2000, and we will create a tunnel from my local port 9001 to the console's localhost port 2500. You will have to adjust this command to use your specific REnigma server address. To do so in this case, the command is ssh-f demo at console.renigma.io-p2000-L 9001:localhost:2500-N. Then, we will use the Ghidra Debugger to connect to the local tunnel port for the REnigma GDB remote debugging server. The specific commands will potentially vary depending on your version of Ghidra. Please see the documentation for your version for how to enable Ghidra's debugger tool. In this case, we click on the debugger icon dropdown, configure and launch GDB remote. Then we will fill out the form with our local port info and click Launch. As you can see, Ghidra successfully connected to the GDB server running in the REnigma console. Now that we are connected, let's take a look at the registers at this execution point. If we right-click on the RIP, we can copy the address in that column. If you press the G character in the dynamic window, you can load that address in the current virtual address space. Ghidra and its debugger also have many other features that you can leverage as well. In the future, we will demonstrate using REnigma to scrape PE files out of memory sections and view them in Ghidra. Additionally, we will demonstrate applying symbols to the code and using the Ghidra code analysis and decompilation capabilities. And that's all for now. If you want to learn more about REnigma or are interested in evaluating REnigma, please visit dtrsec.com. Thank you for watching, and I hope you enjoyed the video.